Hello everyone, I am Abhishek, and in this video I will talk about differentiation of determinants. So here we can see that delta x is a determinant of 2 cross 2 matrix where each and every element of this matrix are functions. So the differentiation of this determinant is the sum of two determinants, where in the first term we can see all the functions in the first row is differentiated, and in the second term all the functions in the second row is differentiated. We can also do it column wise, that is the sum of two determinants, where in the first term the first column functions are differentiated, and in the second term the second column functions are differentiated. Now let us see this example. Here it is given that fx is a determinant of a 3 cross 3 matrix where the elements are functions of x. So it is a determinant of sec theta, tan square theta 1, theta secant x, tan x x, 1, tan x minus tan theta 0. Now we need to find out if dash theta is option A is 0, option B is minus 1, option C is independent of theta, and D is none of this. Now here theta is actually a particular value, that is a constant number, and x is the variable. So we need to find out f dash theta. So before that we will find out f dash x. So let us differentiate the above function. So if we differentiate fx, then first we have to differentiate the first row. Here in the first row each and every elements are constant. So therefore the differentiation of the first row will be all 0. And the second and third row will be as it is. Now in the second term the second row will be differentiated. So we can see if we differentiate the second row, the first element of the second row is theta secant x, where secant x differentiation is secant x tan x, so it will be theta secant x tan x. Then the next element is tan x, whose differentiation is secant square x, and the last element of this row is x, whose differentiation is 1. And here in this term the first and the third row will be as it is. Similarly in the third term only the third row will be differentiated, and the first row and the second row will be as it is, and thus we got the third term as this determinant of sec theta, tan square theta 1, then theta secant x tan x x, then 0 secant square x, and 0. Now if we put theta in place of x, we get this result. Now in this first determinant, if we put theta or not, the value of the determinant will be 0, because that entire row is 0. Now after putting theta in place of x, we get this determinant, and this determinant we get from the third determinant. Now again in this determinant we can see from the first column we can take secant theta common. So after taking secant theta common we get this matrix, where we can see the first and the third column are same. So therefore the determinant of this matrix will be 0. And after reducing this determinant we can write 1 into minus 1 whole to the power 3 plus 1 into the determinant of tan square theta 1, secant square theta 1, which is the cofactor of this one. Now which is equals to tan square theta minus secant square theta plus sec theta into 0. And since we know secant square theta minus tan square theta equals to 1, so tan square theta minus secant square theta will be minus 1. So therefore we can say that this value f dash theta is independent of theta also. So therefore the option will be both B and C. Thank you.